So the first two, all we're doing is adding like terms. So on the first one, I have 6x squared, 2x squared, and x squared. In the middle, I have to remember to distribute this negative through the whole parenthesis when I'm adding them together. So I have 6x squared minus 2x squared plus x squared gives me 5x squared. And then I have an x, which is my next like term. So that would be plus x. And then my next like terms are my constants. And I have 7 minus 3, which is 4. Okay. There's that one. And then number 2, same thing. I have x squared minus 4x plus 7. And then I kind of noticed that this is the same as this. They're exact same terms, and I'm subtracting them. So that means those two cancel out or make a 0. So what I'm left with is 3x squared minus 9. Okay. And then we're going to multiply. You can FOIL this, right? So, or distribute twice, the 2x times both terms, and then the 6 times both terms. So I get negative 6x squared plus 10x minus 18x plus 30, and then combine my like terms, which are in the middle. So I get negative 6x squared minus 8x plus 30 for that one. Okay, Tony. And then on the second one, remember what it means to be squared. What it means to be squared, it means multiply by itself, right? So that means this problem is 2x minus 5 times 2x minus 5. So I'm going to do the same thing, distribute. So I get 4x squared minus 10x minus 10x plus 25. My like terms are here. So I get 4x squared minus 20x plus 25. Okay? So that all should just been a review, combining like terms and multiplying binomials. So a review, like, I know we haven't done it much this year, but in the past several years, you guys have done it quite a bit. So you should be able to be okay with that. And let's see, who did I just let in? We are starting a new unit today. So we're starting unit 3. I put it at the top of the Canvas page. And so you should be able to find it there if you need it. The other thing is, yesterday I was supposed to start a checkpoint for 2.2 and 2.3. Is that right? Sorry, I'm trying to remember. And it didn't quite work for some reason. Again, it won't let me fix the dates. So annoying. So the district is looking into it, trying to figure out what's going on. So hopefully by today I can get you guys a checkpoint, and I'll just extend the day every time. I'll just extend the due date another day. So you'll see the notice. If you get notifications on your phone or whatever, you'll see the notice that it's been activated. So as soon as that happens, you guys will have that. So sorry about that. Okay, so here we go. We're going to go on to factoring. This whole unit is on factoring and factoring different things. So we'll be factoring. The defined factor is just to write an equivalent expression that is a product. An example is if I have 2x plus 4, don't know why I put it in parentheses. It factors to 2 times x plus 2 because what's in both terms? A 2 is in 2x and a 2 is in 4, so I can take a 2 out. So that's just kind of a definition of factoring. It's an equivalent expression that is a product. Okay? So that's what we're going to do for the first set. Write equivalent expressions by factoring out the greatest common factor. So I need, when it says that, I mean, I can, how do I want to say this? If we look at number 1, I could factor out a 2 because 2 goes into 8 and 20, but it says greatest common factor. So I want to take out the biggest number that goes into both 8 and 20. So the greatest common factor in this case is 4. Yeah, 4. So I'm going to factor out a 4 out of both terms. So 4 here, and then I get 4 goes into 8, 2y squared, and 4 goes into 25 times. So you can check to see if you factored correctly, and how you do that is just multiply it back out. If I multiply this back out, I should get my original problem, right? So 4 times 2y squared is 8y squared, and 4 times 5 is 20. If I multiply it back out and I don't get the original equation that they gave me, then I factored it wrong, okay? So just think about that. You can check yourself pretty easily to see if you factored it correctly. So just a little note there. So this part is my answer. Is there any questions so far? Or are we factoring? Factoring's okay so far. Okay, so the second one, what can I take out of 9y squared plus 3x plus 3? Hunter, can we talk about that at the end? Is that okay?
Yeah, that's perfect. Thank you.
Yeah, you're welcome, hun. Okay, so what can I factor out of 9y squared plus 3x plus 3, guys? Anybody? Type it into the chat. Say it out loud. I don't care. What goes into 9, 3, and 3? Well, 3 does. So if I factor out a 3, how many times does 3 go into 9y squared? Well, it goes into 3y squared times. And how many times does 3 go into 3x? Yeah. 1 time. So I can write the 1. I don't have to write the 1. For the x, I could write 1x or just x on this case. And then how many times does 3 go into 3? Well, 1 time. I do have to write the 1 there because there's no variable. So that would be what it factors to. And then you can check it by just multiplying it back out to see if I get the same answer, the same original equation or expression. Okay, so number 3 is a little bit harder because not only do I have a constant that's in common, I also have variables that are in common. Lucia and Tone. So I have both a constant and variables that are in common. So what goes into 24, 18, and 42? I think it's 6. So I can factor out a 6. And then I'm going to kind of look at each variable individually and see what's the largest amount that I can take out of each one. So, and when I'm talking about each one, I'm saying I have this bunch right here. So we're looking at the S's right now. I should make that a little smaller. So I have my S's right here that I'm going to look at. And so I have a S squared in one term, an S in the other term, and an S to the 4th in the other term. So I want to know how many S's I can take out of all 3 terms. So the most S's in, so let's see, how do I want to say this? Sorry. I want to find the smallest number of S's in the 3 terms. So in that case, it would just be this one, S, because the largest amount of S's I can take out of that term, the middle term, is one S because there's only one there. And the others have more than that. That's okay if it has more than that. But the most I can take out of see, there's too many mosts and leasts and everything in there. It's all confusing even in my mind. So the most I can take out of this term is 1. So I can't take 2 out because there's only one S here. And I can't take 4 out because there's only one S here and there's only 2 S's here. So the most I could take out of each of them is 1 S. I hope that kind of makes sense. It's a little confused in my mind even right there. So I hope that if I say it again, it'll make sense if we do it again. So if I look at the T's next, I have T to the 4th, T to the 3rd, and T to the 5th. So again, I want to find the T that has the smallest amount of T's, which again is in the same term, which is here. I have T to the 3rd. So the most T's I can take out of all 3 terms is 3 T's. So I'm going to factor out T cubed. Okay. Please, you guys, make sure if something's not making sense, you say something, okay? So now I'm going to do this one term at a time. So 6 goes into 24 3 times, 4 times. Oh my gosh, 4 times. It's 4. It is 4. Okay, and if I have S squared and I took 1 S out, so that means I'm left with 1 S. And I have 4 T's and I took 3 T's out, that means I'm left with 1 T. So that looks like a 5 instead of an S. So 4ST. And then I'm going to go to my second term and do the same thing. So 18 divided by 6 is 3. And then I have 1S and I take 1S out, so I don't have any left. I have 3 T's. I take 3 T's out. I don't have any T's left, so it's just going to be minus 3 in this case. And then I go to the last term, and negative 42 divided by 6 is 7. Yes, 7. And I have 4 S's in the third term, and I take 1 out, so that means I'm going to have S cubed left. And I have 5 T's in the last term, and I take 3 out. That means I'm going to have 2 left in there. And that's factor. That's it. That's as low as it can go. Okay. So now we have 3 problems. I'm going to try and leave all this on here for you guys. And I want to talk about this again. So the first one, right, the only thing that I can take out is a constant because there's no variable in the second in 35. So what comes out of 10 and 35 is 5. So I would get left with 2x squared plus 7 if I divide it by 5. Sorry, my email notification is going off like crazy. I guess some of you guys had problems getting into Canvas this morning. All the teachers are talking about it, and they're sending emails like crazy because people are having problems with Canvas. So sorry about that. Okay, so on the third and fourth one, the B and C, third and fourth one, second and third one, I'm just going to slow down just a little bit on these ones and talk about them because there was a few people that said they were not quite sure on how to do it. So I'm going to slow down and go over it again. I hope that's okay with you. It looks like most of you guys are doing pretty good. Tony, I just want to say you need to keep hitting for I think your equal sign means plus, right? I just want to verify that in your equations. That's supposed to be a plus sign, right? Okay, good. Okay. So here we go. So I'm going to look at them, and I'm going to look at the variables because the only thing B has in common is all the A's, right? So I'm going to look at all 3 of them. So I have A to the 6 here. I have 6 A's here, 4 A's here, and 3 A's here. So in order to factor out something, I have to have that number in each one of them. That amount in each one. So I have, so I'm going to look for the smallest amount, the term with the smallest amount, I guess. So, okay. So this one, oh my goodness, Kim, I'm so sorry. My brain is just not working this morning. I have an a to the third power. That's my smallest number of a's. So that's the largest number that I can factor out, the largest number of a's I can factor out, because I couldn't take 4 a's out because this term only has 3 a's, and that's the largest amount of a's I could take out of this term. Does that make sense? So because that last term only has 3 a's in it, a to the third power, that's the most a's I can take out of any term, because I can't take any more out of that. So then I just think of it this way. So let's go over here for a second. The rule on multiplying this, if I have like, let's not use a because that example is a. If the rule for exponent says if I have b to the m times b, what the heck? Sorry, let me rewrite that. If I have b to the m times b to the n, my bases are the same, right? My exponents become b to the m plus n. So if I'm multiplying them, I'm adding my exponents. So that means if I'm unmultiplying, which is what factoring is unmultiplying, instead of adding my fractions, because I'm going from one term like this, and I'm going to go back to 2 terms. To go from there, I'm going to subtract it. So I had 6. I'm taking 3 away. That means I get left with 3. Because a to the 3 times a to the 3 gives me a to the 6th. There's another way to think about it. And then in the middle term, I have a to the 4th, and I have 4 a's. If I take 3 a's away, I get left with 1 a. So that would just be a. And then I have 3 a's, and I take 3 a's away. I can't have 0 there. I just want to say I can't have 0. So because when I multiply back out, I want to make sure I have the same expression. So you can also think of it as like a cubed divided by a cubed. What's a cubed divided by a cubed? Well, that's that's 1. The same thing divided by the same thing is 1. So that last one is 1. And I think almost everybody got that correct that put in an answer, which was great, because a lot of times I get people that don't put the 1 in there. So that was good. Kim, did that help at all? Because I think I just totally butchered it.
Yeah, that makes sense.
Okay. Good. Thanks. So on the second one, I'm doing the last one. I'm going to do the same thing. Only this time I have numbers and letters I'm going to factor out. So what goes into 15, 30, and 25? I'm pretty sure that's 5. And then I'm going to look at my variables again. So the first one is m. I have m to the 4th, m to the 5th, and m to the 3rd. So that means I can take out m to the 3rd. And then I have n squared, and n to the 3rd, which means I can factor out an n. Oops. An n by itself. So if I factor that out, 5 goes into 15 3 times, and I have m to the 4th divided by m to the 3rd, which is m, and n divided by n is 1, plus 30 divided by 5 is 6, and m to the 5th divided by m cubed is m squared, and n squared divided by n is n. 25 divided by 5 is 5. M cubed divided by m cubed is 1. And n cubed divided by n is n squared. Okay? Questions? Okay, awesome. Whew. Okay, so we're pretty much doing the same thing here, except the directions say I want to factor out a negative coefficient. So whatever I factor out has got to be negative. So I'm going to factor out a negative number no matter what, or a variable. Negative number or variable, whatever I'm factoring out has to be negative. Okay, so, but basically I'm doing the exact same thing that I just got done doing, but I'm going to factor out, and I need my calculator because I need to know if 96 divided by 16, yes. Okay, so I can factor out a negative, if I can get a pen here, a negative 16, because 16 does go into 96. So if I take a negative 16 out of negative 16y squared, I get y squared, and then I get negative 6. Okay, questions? And then the second one, they want me to factor out a negative, so I have to factor out a negative. So what goes into both a negative x squared and a negative 100? Well, a negative 1 does. So that will give me with x squared plus 100. That's it. Okay, I'll give you like 2 minutes. Is that long enough to do those? So if I'm going to factor out a negative number on A, what goes in both 7 and 35 is 7. So it looks like a couple people factored out only a positive number. But remember, my directions say I have to factor out a negative number. That means I'm going to factor out negative 7. Okay, because it has to be negative. That's what the directions said. Normally I would factor out just 7 like what you guys did. That's awesome. But because my direction says it has to be negative, then I have to factor out a negative. That just means this is going to be negative 1 plus 5t. That's it. Okay? And then the second one, I'm going to factor out negative 5, it looks like. And I'm going to get x plus 8. Awesome job. You guys did great on the second one. Forgot to factor out a negative on the first one. Except some of you did factor out a negative on the first one, so thank you on that. Nice job on factoring. So now we're going to move to a different type of factoring. It's called, and I didn't even put the name on here, and we're going to do it in steps. So we're going to start with it already kind of factored and then kind of move up, but it's called factoring by grouping. By grouping. Okay, so I'm going to factor by grouping because I'm going to group things together. That's why. Okay, so on the first one, I want to see what I have in common, right? That's what factoring is. What does it have in common? So this is in both terms, and this is both terms. So let's define what a term is. A term is a series of things multiplied together that's separated by a plus sign. Okay, so here are two things that are multiplied. These are multiplied together, and these are multiplied together, and it's separated by a plus sign. So here's my two. I have two terms here. Even though I want to say there are plus and minus signs inside the parentheses, that doesn't make that doesn't make each individual term, I guess I want to say. The parenthesis defines one term. So this is one term or one expression together, and then it's multiplied by another expression. So that whole thing, this whole thing here is one term because it's multiplied together. And sometimes people have a hard time understanding that part. So that's why I'm trying to explain that here. And then this is one whole term because it's separated by a plus or minus sign. It could be separated by a subtract sign. That's fine. Subtract sign is the same as a plus sign in this case. So I want to find out what it has in common. And what it had in common was that x plus 7. So I'm going to factor out x plus 7. So I can factor out x plus 7. Okay, and well, what does that leave me with? Well, if I take an x plus 7 out of the first term, I get left with this part. This is what's left. And out of the second term, what's left is this. So I've got x minus 1, I'm going to put that in parentheses, plus x minus 2. Now, just like in the warm-up that we did when we combine like terms, I can take this part of my my expression and I can add those together because there's no multiplication. There's just a plus sign between them. So I can combine those like terms together and make it more simplified. And this becomes, I'm going to write it here, x plus 7 times 2x minus 3. Yeah, that's right, 2x minus 3. Okay? Questions? We're okay so far? All right. The second one's a little easier because it doesn't have two sets of parentheses. It just has a term and then a like term multiplied together. So I've got this x minus 6. What are my like terms? The x minus 6. So my like term, I'm going to factor out my like term, which is x minus 6. If I take out x minus 6 from my first term, what do I have left? 5x squared. And if I take it out of my second term, what do I have left? 2. So it'd be x minus 6 times 5x squared plus 2. And you can kind of, I think this one's a little easier to see. If I distribute this back out, this times this, I'm going to take this whole thing because that's what they did, and then times this, you do get 5x squared times x minus 6 plus 2 times x minus 6. So they just distribute it back out. That's how they did it. So there's another way to kind of look at it, I guess, to make sure that I've got the right answer. So I want you guys to go ahead and try A and B and C and D, I guess. Sorry, I didn't realize that there was 4 of them. So try those ones. Okay, here we go. So on the first one, I've got a plus 5, and a plus 5 is my common factor. So I'm going to factor that out, and I get a plus 5 times a minus 2 plus a plus 1. So that would give me a plus 5 times 2a minus 1. Okay, and then the second problem, let's see, my common factor is t minus 3. So I would factor out t minus 3, and I get left with r minus s. And part C, the third problem, I have b minus 5 as my common factor. So I can factor out b minus 5, and that leaves me with a plus c. So now that leads us to D, and if I look at my parentheses, they're not the same. I have x minus y and y minus x. They are not the same. Nice, Tony. Oh, okay. Oh, okay. Thank you. But I can change. Oh, Toe is here. I can factor out. If I factor out on the second problem, if I factor out a -1, that changes my y minus x to x minus y. So I'm going to do a little factoring first before I actually factor. Oh my gosh, that's too many factoring. A squared times x minus y. And then if I factor out a -1, this becomes -5. And then I get x minus y. It changes my signs, right? And now now I have the same terms inside my parenthesis. So I can say this is x minus y times a squared minus 5. Okay? Questions on that? And I just let somebody in. Who did I let in? It was Toa, right? Okay, great. Awesome. Okay, so now we've done it. So kind of this is already the second step, I guess I would say, that we've done. Now we're going to go from the beginning. Okay, so what we have to do is break them into groups. So we're actually going to group them. So I'm going to group them into two pieces. I'm going to group them here and here. And this is where the name came from, factoring by grouping. I'm actually putting them into groups and going to factor it now. So if I look at my first group that I made, xy plus xz, what can I factor out of that section, that first section? X plus y and x plus z. Well, there's an x in both of those terms that I made. So I'm going to factor an x out, and I get x times y plus z. And if I look at my second group I made, I can factor out a w, because there's a w in both terms. And then I get y plus z. And now look, now I'm right back up to what I was doing up here. Okay, so when I'm factoring by grouping, I want to be paying attention to one thing. If I get this inside my parentheses when I factor by grouping, I better get the same thing in my second group. So I want to make sure that when I set up my groups that when I factor out, I'm going to get the same thing inside the parentheses when I factor out. So then the next step, because if I don't do that, then the next step doesn't work. And the next step is what we've been doing above, where I can factor out a y plus z and get left with x plus w. And there's my answer. So if I multiplied this out, I would get this. Is there any questions? Okay, if there are exponents, I want to talk about this too, because I don't want to say variables, because this first equation has all variables and there's no way to put it in order, right? But if there are exponents, right? So I have y cubed, y squared, y to the first power, and then no y's. I want to make sure that they're in order from greatest to least. So I want to make sure they're in standard form. And standard form means that the exponents are in order from least to greatest. Greatest to least. Wow. Biggest to smallest, or biggest to none. There should be no exponents left when I'm done with this. So I'm just going to rewrite this first. So y cubed minus 3y squared minus 2y plus 6. Okay, so I want to make sure my exponents are in order from greatest exponent to no exponent, basically, to my constant. So 3, 2, 1, 0. Is everyone okay with that concept? Okay, so now I'm going to group it. So I'm going to group the first two together, and I'm going to group the second two together. So let's see, in my first set, it looks like I can take out a y squared, and I'm going to get y minus 3. And then in my second set, it looks like, and I hate that I put my parenthesis there, so I kind of have to be a little careful. I'm going to make this small so I don't erase anything, because this is a negative 2y. So I could have actually written this. Let's see if I can write this. So this would be a minus, and then I could put a plus here, and then my parenthesis could go here. Okay. Okay, so plus a negative 2y plus 6. Because what I need to do, I need to make sure, remember when I said I needed to make sure that my second parenthesis was y minus 3? And right now my constant term is a plus 6. The only way to get that plus 6 to become a minus 3 is to factor out a negative 2, right? So if I factor out a negative 2, then I get y minus 3. Because I factor a negative 2 out of negative 2y, and that's why I kind of wanted to rewrite that a little bit. And it's still perfectly legal. It's still the same thing, perfectly legal. Wow, it's still the same thing. It still says plus negative 2y and plus 6. It didn't change anything. It just changed the perspective a little bit and factoring out a negative 2. And then I can rewrite that. Then I have my like terms, which are the y minus 3 and the y minus 3. How are we doing on time, you guys? Oh, we're doing great. Okay, so I've got y minus 3 times y squared minus 2. Okay? Not too bad. Okay, so sorry I forgot to write directions here on this page, but we're just factoring by grouping, so we're doing exactly what we just got done doing. So I'm going to give you a few minutes to work on that before we talk about it. So let's go ahead and do this. We've got, let's see, what do we have here? If I group those two together and those two together, I factor out an A and I get C plus D. And I factor out a B and I get C plus D. And then I factor out a C plus D, and that leaves me with A plus B. And you know, it doesn't matter what order you write those in, right? I could have written A plus B times C plus D. It doesn't matter what order you multiply them in. I mean, you write them in. So either way is right. So let's see. I can group those together, and I'm going to factor out a y squared, and I get y minus 1. Factor out a 3, and I get y minus 1. So y minus 1 gives me y squared plus 3. Beautiful. I might want to talk about that. We'll see. And then I factor here and here, here and here. So let's see. B squared gives me b minus 1 plus 2 gives me b minus 1. So b minus 1 times b squared plus 2. Yeah, okay. And then the last one would be t squared is t plus 6 minus 2 would be t plus 6. So I get t plus 6 is t squared minus 2. Okay, so I do want to just say this, that's it. If there's no questions, awesome. I do just want to put, I don't know if I want to say, I do want to say this. If this happened to be a slightly different problem, D, and it factored to this, t plus 6 times t squared minus 4, on the homework or on the Delta Math, you would have to factor the t squared minus 4, even though we haven't got to that yet. I hope that you remember how to factor it. You would have to factor it, and it would factor to t plus 6 times t minus 2 times t plus 2. And we're going to get to this in the next day or two on factoring this. I hope that if you remember, I hope that you remember how to do that. But it will be, I think I tried to get problems that weren't like that, just so, because we haven't gone over that yet. So I hope that it's not there. But I did want to point that out, that there's a possibility there might be, if this number is a perfect square, like 4, 9, 16, 25, which it probably won't ever get that big, then you would have to factor that, this t squared, factor this part right here again. Okay, so just wanted to put that out there.